Okay, good morning, good afternoon, or good evening, wherever you happen to be in the world today. Today we're going to talk about risk analysis and analytics using Safran Risk. My name's Ian Nicholson. I'm VP Solutions here at Emerald Associates. I'm a risk analysis trainer and consultant with Emerald Associates. I've done schedule and cost risk analyses in many industries. I actually started using risk analysis on cost estimates for construction projects back in the late 90s. I started working with schedule risk analysis when my company became the Canadian Pertmaster reseller in 2001. Joining me today is Lynn Baxtrom, who's an implementation specialist with Emerald Associates. Lynn has many years of project controls experience in a number of different industries. And she's an expert on both scheduling and on risk analysis. So why would we conduct risk analysis? Well, the whole idea behind risk analysis is to help our project teams and executives understand and manage the risks on their projects. We want to get the project team discussing and understanding the challenges of their projects. We want to keep the project team focused on the right issues. Oftentimes they get so hyper focused on the wrong issues that they start missing the things that are likely to actually impact the project. Okay, so things like, sorry, my dog's in the background. Things like near critical paths that can come and haunt the project team. We're always taught as project people that we should spend all of our efforts managing the critical path. But what happens is we do such a good job in managing the critical path that, surprise, surprise, by the time we do our next schedule update, it's no longer the critical path. So risk analysis is a requirement of many companies' gate approval processes. And although it is required, that's not really why we should do it. The reason we really want to do it is we want to understand the dependencies between cost and schedule and understand what's likely to derail our project. Now, I'm in Alberta. In our part of the world, there's a group called the Construction Owners Association of Alberta, and they put out reports on mega projects in our part of the world on an annual basis. And as far back as 2009, they recognized that project risk assessment is shown to significantly reduce project cost growth. So ask yourself, do you build detailed CPM schedules? Do you develop detailed estimates? Well, of course you do. Everybody does. But the chances of meeting your project schedule and financial goals are still typically less than what you'd like them to be. So how is that possible? Well, we do detailed CPM scheduling, but there's a problem with what we do. And the problem is that everything that goes into our CPM scheduling tool, like P6 or Microsoft Project or any of these other tools, is the data is entered in finite values rather than ranges of uncertainty. So we go in and say, okay, this activity is going to take 4 days, 3 people at $100 an hour. Well, the problem with that is that the assumptions can change over time and maybe they no longer match reality. So maybe our activity is going to take 5 days and it's going to take 4 people, and now those people cost $125 an hour. So we're going to have a significant change in the scope, timing, conditions around our project. We might plan to start a project in the spring and things get delayed. So now we're in the fall and we have to deal with a winter construction. Or, we might be in a situation where um, the project was planned when oil was $30 a barrel and now oil is $100 a barrel. So all of our construction costs are going to go up significantly. So all these kind of things can have a big impact on our project. Now we do detailed estimating, of course, but we have similar problems. Um, and one of the big ones that we have is that estimators may be too optimistic or too pessimistic. Now, when we put things in a bid process, we're encouraging aggressive estimates. We've all seen that cute little cartoon with the big yacht and the little boat, and the little boat is called base contract, and the big yacht is called change order. Um, what happens a lot of times, and this happened when I used to work in construction, is we would bid jobs at cost and then hope for changes that would make us profit on the project. So we're being super aggressive in our approach to try and land the work in the first place. Now, the other thing that can happen is kind of the opposite problem, and that estimators can add contingency and they kind of hide it here and there throughout the project. The problem with that is we can't really manage that contingency. We don't know where it is. It's not visible. It's kind of hidden. So it's very difficult for us to manage that. Estimates can be built on historical experience that may no longer be valid. So again, we might base it on the idea of $30 a barrel oil, and now it's $100 a barrel. And estimates may not scale to match the project. Oftentimes we do a pilot project and then we just scale it up to do the final project. And projects don't necessarily scale linearly. So all these items are deterministic. So why is that a problem? Well, deterministic estimates don't take uncertainty into account. And uncertainties can build on one another to make the project very different from what we originally planned to do. Now, um, on top of that, historically, there's been no easy way to model cost uncertainties with the schedule. So we all know that our schedule and our costs are intrinsically linked, but it's been very difficult to build one model that shows us both the cost uncertainties and the schedule uncertainties so that we can look at the interdependencies between them. What we really need is a probabilistic cost and schedule risk model all in one place. Going back again to the Construction Owners Association of Alberta, on average, Alberta-based mega projects experience a 19% project cost growth and a 17% project schedule growth. So again, these are quite tightly correlated. If you're running late, you're going to spend more money. There's really no way around it. So again, we want to understand what those dependencies look like. So we need to be able to model our schedules and costs more accurately. We need to limit our financial exposure. We need reproducible results. So we need a good methodology and an audit trail of what we've done. We need to improve the likelihood of project success. We need to give our project team confidence in the results that we give them. We need buy-in from the team. We need to increase our maturity in conducting risk analysis. And finally, we need to store everything in a common database so we're not managing a whole bunch of flat files all over in directories here, there, and everywhere else. Well, I think the best solution on the market for that is Safran risk analysis. So it allows us to put ranges on our estimates. It allows us to model risk events. It allows us to model costs and schedule together. Um, and when they're not linked, we can model them separately. And I'll talk about that when we actually get into the software. It lets us model detailed logic uncertainties, so we can build very sophisticated models about what could go wrong in our schedule. And the idea is this allows us to understand the probability of achieving our end dates and costs. It helps us understand um, what the key drivers are in our project and what their effects are on the project. We can run different scenarios very quickly and easily, and that will help us develop mitigation strategies that we can actually implement. All right, so enough talking. Let's dive in and look at the software. Okay, so this is Safran Risk. Now, Safran Risk, when you come in, gives you a welcome screen. On the welcome screen, you have the ability to open an existing project. You can import an external file. So if you have a P6 file or you have a Microsoft project file, you can import that into the system. It also gives you a list of the recent projects that you've worked on. Um, And I'm just going to open up one of the projects that I already have in the system. I'm going to open this one called UAV Prototype. So this is a pretty simple little project. What it is it's a project that is building an unmanned air vehicle. And what we're going to do is we're going to build this vehicle and then we're going to test it and hopefully get it to market. Now you'll notice that when I open up the system, a whole bunch of tabs appear across the top of the screen. Now, the idea with Safran Risk is that we're basically going to have a workflow here. We're going to start on the left, which was our home screen, and we're going to work our way to the right, going across each of these tabs. So this makes it very nice because everything's kind of workflow driven as opposed to being menu driven in older tools like Primavera Risk Analysis. Um, and when I open up my schedule, the first thing it does is it takes me to my Gantt chart. Not surprisingly, I can look at my schedule. Now, this is a fully functional scheduling tool that's included with Safran Risk. It's built on Safran Project, which is a competitor to P6 in Europe and the Middle East. So it's fully functional. You can do all the things that you might want to do. You can add or remove activities. You can change logic. You can change resource assignments. Any of those things that you might want to do, you can do in here without having to go back to your original schedule every single time. Um, you can also turn on filters, and you can change your grouping and sorting. So you can do all these kind of things that you would expect to be able to do in a scheduling system. One of the nice things about this is that if I turn on a filter in this screen, that filter will carry through the rest of the tabs. So if I want to focus maybe on the design part of the project and I'm not so worried about construction yet, what I can do is I can put a filter in here to just show me the design activities. And as I go through the rest of the tabs, my activities will be filtered to only show design. So that's kind of useful when you're working with really large schedules and you want to work with smaller subsets. It just makes everything a little easier to manage. There is a schedule warnings tab, so I can make sure that my schedule's in good shape and there aren't any issues that I might have around this schedule. So it's going to show me things like, if I've got some constraints in my schedule, if there's lags in my schedule, if there's missing relationships or open ends, it will show me that as well. So I can make sure that my schedule is robust enough to do risk analysis. Now, if there's something that perhaps I want to go and look at, maybe one of these is something that concerns me a little bit. What I can do is I can just click on it, um, and I can right click and say go to schedule, and it will take me right to that activity. And then I can make sure that I'm happy with whatever's going on in that particular activity. This updates in real time. I don't have to go and run a report or anything like that. I can just basically, if I fix something and go back, it will drop off the list. So it's really powerful from that perspective. So once my schedule's in good shape, I can go to my project risks. And the idea here is I can put all of my uncertainties and all of my risks in one place. So we have this risk register called project risks. Now, these risks can be schedule risks, they can be cost risks, they can be uncertainties, or they can be risk events. Everything basically that you're going to deal with is from a risk perspective goes into this module. Now, a risk can be schedule only, it can be cost only, or it can be both. And so if I take one of these, like for example, my ash cloud, what I can do with this is I can first of all define if it's a schedule impact, if it's a cost impact, or in this case, it's both. Now, I can make, for this particular risk, I'm saying there's a 40% probability that this risk will occur. So it has a 40% on it. And then I can say, what is the impact going to look like if it does fire? So it can be a relative impact, which is a percentage of the original. So in this case, I'm saying that my duration will go anywhere from 100% of the original duration of the activity up to 165% of the duration of that activity. So if it was a 10-day activity, it would go from 10 days up to 17 days. For my cost impact, I've said that it is a distribution going from 80% minimum, 100% most likely, and 150% maximum. So you can see these distributions can be different because in some cases, if something happens, it'll save you money, but cost you time, or vice versa. The other thing is that I can make my impacts absolute. So rather than make them relative, I can just say, if this thing happens, I can define the number of days that this will impact my schedule. So I have both options in here. I can have an absolute impact or I can have a relative impact. Now, I can also define, this is my pre-mitigated position, but I can also define a post-mitigated position for these risks. So if I'm going through my mitigation strategies, I can track all the things that I'm doing as part of my mitigation. So I can add activities which will add duration to the overall schedule, and I can add cost items. So if I'm going to do a study, for example, to say, okay, what can I do about this ash cloud? Maybe I need to look at moving somewhere else. So what I'm going to undertake a study as to what other locations I could move this project to where my flight testing wouldn't be interrupted. So in that case, I could add a duration and I could say, you know what, it's going to take us 30 days to do this particular thing. And what I can do is I can link it to one of the activities in my schedule. So I'll just grab one here. So I can just add one in, and similarly, I can add a cost in, and I can add the cost into one of my cost elements. In this case, perhaps in my other costs under transportation. So I can go and I can define what my mitigation strategy is going to cost me. And then I can define what my post-mitigated probability and impact is going to look like. So I have this ability then to build these scenarios where I can say, okay, I'm going to spend a bit of money. Where am I going to end up? Am I going to end up better off? Because sometimes when you're actually doing risk analysis, you find that your mitigation strategies um, cost you more than they save you. So in that case, you would probably just accept or try to avoid the risk rather than try and mitigate the risk. So um, let me just remove those because we're not going to actually build them into our model. Um, the other thing is that I've got different risk types in here. So the first one is I've got standard risks, which are the ones that have a percentage of likelihood of occurrence, and that can be from 1 to 100%. I also have calendar risks. So in this case, what I can do is I can set up a probabilistic calendar, perhaps for bad weather or um, strike or anything like that that I want to model where I can't work on this particular activity. So my probabilistic calendars will say, you know, this is a non-work day, and anything that's been assigned that probabilistic calendar will then skip that particular day. So, you know, again, it could be winter work where I can say, okay, there's a 40% chance that I'm going to lose 3 days in January due to bad weather. And I can assign these to my activities. I'll show you how to do that in just a minute. The other thing is I can have a probabilistic branch. And the idea with a probabilistic branch is I can have a point in my schedule where I say, you know what, we could go on any number of different ways. Um, so what I might say is, you know, we're going to come into a test that if we fail the test, we're going to have to do a whole bunch of rework. But if we pass the test, we won't have to do anything. We're good to go. So I can define a probabilistic branch in here as well. And I'll show you how that works when we get to that section. But I can define, again, this in my risk register. I can also define if an activity may not exist. So sometimes I have the situation where I've got an activity in my schedule, but maybe I don't need it, right? There's a possibility that I'll get something fast tracked and I won't have to go through 3 levels of government approval. I can only go through 2 levels of government approval. So I can define this as a non-existence risk. So again, what I can do is I can say, okay, there's some kind of um, probability that I won't have to do this work. In this case, I'm saying there's a 10% probability that I won't have to do this. Now, I've also got these last ones down here, which are estimate uncertainties. Now, the idea with estimate uncertainties is they're just general uncertainties. So they're always 100% likely to occur, and they're just generally range uncertainties. So I might say, okay, on my schedule, maybe I'm sitting at, you know, 95%, 100%, 105%. So I've got a plus minus 5% estimate number in here. For my medium estimate uncertainty, I've got, you know, minus 10 to plus 15. And on my high estimate uncertainty, I've got minus 20 to plus 50%. Now, how are these different than standard risks? Well, they're different in a couple of ways. The first thing is that they're always 100% likely to occur. And the second thing is that when I get to the risk mapping, I can choose as many standard risks on an activity or on a cost line item as I want, but I can only choose one estimate uncertainty because the idea is you wouldn't have low estimate uncertainty and high estimate uncertainty on the same activity or cost element. You'd have one of the other. Okay, so let's move on now. We're going to move to the risk mapping tab. Now, the idea here is, let me just open this up. Here's where we're going to map our risks to our activities. Now, I'm going to show you in just a couple of minutes how we map the risks to our costs and how we map our costs to our activities. So if you're interested in the cost side, just bear with me for a minute. I will get to that. All right. So the first thing is, and let me just um, turn this off. I will come back to it in a moment. Okay. So first of all, if I choose a particular activity, for example, I have this agree contract activity, and let me open this up a bit. So the first thing is, on my agree contract activity, here are my estimate uncertainties, right? I can have no estimate uncertainty. I can have low, medium, or high. Those are the ones I defined in the previous tab. Now you'll see that these are shows up as radio buttons. So if I choose one of them, the other one turns off, right? I can only choose one of them, or I can choose none, of course. So again, whichever one I happen to choose, it turns the other ones off. To the right of that dividing line is where I have my normal or standard risks. And in this case, I can choose as few or as many risks as I want. And they're shown up here. Here's the ones that have been chosen. And I can say whether I want to link them in series or whether I want to link them in parallel. So sometimes when risks fire, they fire concurrently, and it doesn't cost me any more time, but other times I have to complete one before I can do the next. So in that case, I end up in a situation where I want to link them in series. So I have this ability to choose whether they're linked in series or in parallel. The system shows me, here's the probability of each of these risks. Here's what the impact looks like, right? This is my pre-mitigated position. So this is all great. It's very useful, but really what I might want to do is I might say, you know what, on this particular activity, I want to change the percentage. So keep in mind that a risk can be associated to many activities. Maybe I want to override the standard impact um, and change it to something else. So I have the ability to do that here as well. But we've got a whole bunch of different risks on this particular activity. And one of the things we always used to struggle with when I used to work with Primavera risk analysis was, okay, what if I have multiple uncertainties or multiple risks on one particular activity? How do I put all that together, and how do I model it so that all those different risks come together and show me what's going on? And in Primavera risk analysis, they made a sort of a half step in that they came up with the risk register for risk events, and they came up with risk factors for uncertainty, but it never really kind of worked very well together. But in Safran, they've taken it a step farther, and what they've done is if I click on the schedule impact section down at the bottom, it says, okay, here's all the risks that you've put on this particular activity. Here's what the overall distribution shape will look like. So the system basically goes off and does a little Monte Carlo analysis every time you add or remove a risk. So this is what my overall distribution shape is going to look like with all of these risks that I've defined. So there's my procurement delays, there's an external communication risk, there's a governance risk, and then there's my estimate uncertainty risk. All of those together make this activity look like this. And it actually shows me here that this black bar shows me the deterministic duration, which was 10 days. And here's my mean distribution, which is 17 days. And you can see that my worst case scenario in that analysis is 43 days. So that's a long way from my 10-day original activity. But again, this could be valid, but it lets me preview it and decide. So if I put a risk on here that had a huge impact that took my 10-day activity and made it 300 days, it would probably not be valid. But as I turn things on and off, so if I were to add another risk to this particular activity, let's say I'm going to choose the merger or acquisition risk. It immediately adds it to the list, and then it redraws again. So I can see immediately what the impact of that risk was. Again, I can turn it off, see the distribution, turn it back on, and see the distribution. So it allows me to do a quick preview and make sure that the risks that I've associated with this particular activity are valid before I go and run all my analysis and everything else, and I have to hunt down why all of a sudden my project is going way late. So it's a very useful little preview to kind of a sanity check to make sure that what I'm doing makes sense. Now, again, I have my, um, I can put my uncertainty, or sorry, my probabilistic calendar in here as well. So that would show up as well. So what I can do is I can choose, in this case, we had this winter non-work. I can go and assign this to as few or as many activities as I want as well. So if I have a probabilistic calendar, I assign it the same way. And again, I can choose one activity or I can choose many activities. Now, I can also do it fairly quickly if I go down to the um, if I go to the on-site testing phase of my project. I could say, okay, you know what? My non-work calendar is going to apply to everything in that particular WBS. So rather than click each one individually, I can just click the header and it will assign that to all of these activities automatically. Um, and again, as I said before, any filters that you put on back on the schedule screen will come through here, as will your grouping and sorting. So right now I'm grouped by WBS, but if I were grouped by maybe an activity code for, phase of the project or location or responsibility or anything like that, it would group by those. So it makes it very easy for me to work with this. Now I'm just going to turn off that non-work calendar before we go any further. And I'm going to come back. So if I was building this normally, the next thing I would do is I would go to the cost tab and I could work on my cost estimate. I'm going to skip that for now. I will come back to it because I want to spend a bit of time on the cost and how I link the cost to the schedule. So we'll come back to this one. I'm going to go on to look at correlations. Now, again, going back to Primavera risk analysis, you could build correlations in the tool, but the correlations were kind of difficult to work with. You basically correlated your activities together, which kind of made sense if you were like saying, okay, I've got 50 piling activities, I'm going to correlate them all together to say if one goes long, they're all going to go long. But it got very complicated when you started getting into activities that had multiple risks on them, because you might say, okay, I've got the same procurement risk on these two activities, but they're being done by different contractors. So if I don't want to really correlate them together 100%, because only part of the risks are correlated, not everything. So what Safran did is they allowed us to actually correlate our risks together. So they developed this little matrix, and let's just turn some of this stuff off so it's a little easier to see. So let's just look at our pre-mitigated information, and for now we'll just look at our schedule information. And the idea here is that what I can do is I can actually correlate the probability that a risk is going to occur, and the impact of that risk against any other risk. So it allows me to very quickly go in and say, okay, if there might be a correlation between my outsource and my merger and acquisition risks. So if we get acquired by somebody, they're probably going to outsource a bunch of the work. So I can build that correlation into my model. And I find this works very well and it's very effective when you've got large models with a whole bunch of risks that are kind of all spread all over the place. You've got many risks on many activities, and this works very well. All right, so let's move on. Now we're going to go to the Analyze tab. Now, again, we haven't done anything with our costs yet. We're going to come back to that, but we're going to look just at our schedule for now. So the first thing is, on the Analyze tab, we have the ability here to turn risks on or off. So, I could say, okay, I'm doing my analysis and I want to run the analysis as in a what if scenario by turning off a particular risk. So I can just clear that risk and rerun the analysis, and it will ignore that risk completely. So rather than have to make a whole new file and save it and run that file, I can just do these scenarios very quickly. I can also choose to run some of my risks in a post-mitigated position and some of them in a pre-mitigated position. So again, I can do a lot of scenarios where I can say, okay, what if this happens? What if that happens? So again, it allows me very easily to do these kind of what if scenarios to really understand what's going on in my model. Now you can set the number of options that you want, or sorry, the number of iterations that you want to run this. In this case, we're going to run 1,000 iterations. You can run Latin hypercube or Monte Carlo simulation. You can include or exclude your correlations. So if you're using correlations, you can toggle them on and off just to see what the results look like. You can resource level if appropriate, after each iteration. And we're also going to turn on the step through function because I want to show you what happens. Now, just before I run the analysis, there's a couple of other options here, and that's that I can have focus activities and focus costs. So why is this useful? Well, a lot of times when you're working on a large schedule, there is a lot of activities at the back end of the schedule that you don't really care about. Things like site cleanup, contract closeout, any of that kind of stuff. Because what I really care about is just getting to the point where I turn this thing over to the owner, right? So that whole transfer of care, custody, control, TCCC. That's what I care about, and that's some intermediate milestone in the schedule, and it's not um, it's not the last activity. So I don't really care about what the last activity is. So the idea here is I can define that as a focus activity, which means that when the system runs, it will allow me to do extra analysis around that activity, or if I create a focus cost around that particular cost. So just a really easy way to come in and say, okay, I really care about this intermediate milestone. This is really what I'm driving towards, and I want to understand, and therefore I can make it a focus activity rather than delete everything that comes after. All right, so let's run the analysis. Now it takes me to the Gantt chart, and I can step through. And as I do, you'll see that the schedule moves. And the idea here is I can just go up and down and move up and down in the schedule, and just make sure that things are moving the way I expect. Okay, so again, and if I've got some probabilistic branching in here, I want to make sure that my branches are firing the way that I expect. All that kind of stuff. I just want to make sure things are working properly. So I've got a little probabilistic branch right here, which is going through my GPS system. I'm doing some testing, and it passes or fails. So as I go through each iteration, you can see the logic changes as it goes through the various branches. So I want to click through, make sure that's working, just kind of make sure everything's flowing the way I expect, make sure that some intermediate milestone isn't stuck because of a constraint. When I'm happy with that, I can just hit complete, and the system takes me to the histogram, which is pretty standard for risk analysis tools. Um, just a quick overview in case anyone here hasn't seen these before. The idea here is each bar represents how many hits I had for a particular date. So in this case, my earliest date is September the 1st, and I had probably 3 hits for that date. And you can see as we go up, we get this distribution shape. The highest number of hits came around, around the 1st of May, and I had about 181 hits there out of my 1,000 iterations. Now, what the system does is it then adds them all up and says, okay, this cumulative line represents the total number of hits that we had um, out of our 1,000. So by the time we get up to the top here, this represents every single iteration of our schedule, or 100% of our iterations. And it says, the latest that we ever got was 2024, February 19th, which was an extreme tail end out here. So the idea here is I can look at any of those percentages. So if I look at the 70% line, this is my P70 value, which is 2023-04-20. And what the system's telling me is that 70% of the iterations occurred on or before this particular date. So if I can go to management and say I'm 70% confident we'll finish by April the 20th. Now, it's not the same as saying we'll finish on April the 20th. I'm saying we'll finish on or before April the 20th. And I can look at that for any particular percentage I want. So if I look at my 80%, I need about an extra 3 weeks worth of time to get to my 80%. Now, my original deterministic value, which was October the 20th, is way down here, and that's what this little line, arrow here represents, the little blue arrow, and it's saying that's only 2% likely to occur. So in 2% of our simulations, we finished on or before the deterministic finish date. Okay, so there's a lot of information here, and it's very useful. The shape of the curve tells us a lot too, because we can see, you know, the inflection of the curve. For example, we're seeing that we have quite a few hits here, and then it kind of drops off, and then it picks up again. There's probably some risk event that's firing that's causing this peak here. So again, we can dive into that more if we need to, but this is kind of telling us overall where we're likely to end up. Now, remember I talked before about my focus activities. Well, I can click on that and I can just go to either of those focus activities that I chose, and I can see exactly, what's the probability of that particular um, activity being completed on time. So in this case, the probability of it being done by the deterministic date is actually 0. It never occurred. And that was 2021 11/23, so November 23rd. It looks like we're going to need about 3 months contingency to get to our P70 value um, for this particular activity. So this helps us define, what our contingency needs to be and where it needs to be in the schedule. So to get to our finalized design, we're going to need some contingency to get to our P70 confidence level. Now, if I turn that off, I can always, of course, drill down to any particular activity that I want to take a look at. So if I don't have it defined as a focus activity, I can still go and look at it. Um, but the advantage of having the focus activities is I don't have to drill through my whole structure looking for it. A couple of other things I can do here. Actually, let me go up to the top of the schedule again. Um, the other thing I can do is I can look at this from a data view, and I can see for each iteration that I ran, which risks fired in that simulation and whether they had a positive or negative impact on my overall results. So the boxes, you'll see that there's some green boxes, some pink boxes, and some red boxes. So green means it had a positive impact on the schedule. Um, Pink means it had or light green means it had a weaker positive impact. Pink means it had a weak negative impact, and red means it had a strong negative impact. And similarly, I have dollar signs on the cost side that let me know whether it had a positive or negative cost impact on my overall schedule. Now, that's kind of interesting just to kind of see what was happening in each of these. But what I can also do is I can sort it by duration, for example, and I can say, okay, on my best case scenario, um, which was iteration 248, my overall duration was 560 days. And here's why it turned out well, because none of my negatives fired, but some of my positives did. So that's why I ended up in that scenario. Similarly, I go the other way and say, well, there's my worst case scenario, 1,075 days, so twice as long as my best case, and here's all the risks that fired on that one. So again, useful to kind of go and see what's going on. I can even go um, off of one of these, and I can even click on the iteration number, and it will show me the Gantt chart for that particular iteration. So again, if you want to kind of see what happened, if something doesn't seem to make a lot of sense, you're trying to understand why it went so far out, you can click on it and it will actually show you that iteration of the schedule. So you can say, okay, now I understand. I can see this one activity went super long, and then go back and figure out why. Okay, let's move on. We also have our drivers or our tornado plots. So the nice thing about the tornado plots is they tell us what are the things that are having the biggest impact on our overall project. Now, again, we can still focus on our focus costs or focus schedule activities, but the system will show me, because everything goes back to the project risks, all my risks are in one place. It will also show me which risks are driving our overall project. So in this case, the ash cloud is having the biggest impact, followed by e-communication, followed by procurement. Um, The activities that are driving the project are also listed in a separate tornado. So again, I can look at either one of these when I'm trying to understand what's going on in my model. Typically, what I'll do is I'll start at the top and work my way down because these are the big impacts and these are smaller impacts. And for kind of obvious reasons, this is called a tornado chart. Now, um, the project team will often say, okay, you're telling me that ash cloud has this big impact and has an impact with a correlation of 0.52, and e-communication has a correlation of 0.50, and procurement delays have an impact of 0.373. But I'm a project manager, that means nothing to me. What I want to know is if I can get rid of this risk, how much time am I going to save on my project? Well, the next tab will answer that question, and that's called our sensitivity analysis. Now, again, going back to my days of working with Primavera risk analysis, if we wanted to do this kind of analysis, we would, which is called analysis by exclusion. So we turn the risk off, we run the model, and we look at how much the model changed. Now, if we've got 100 risks, we would have to actually do 100 iterations of running the model to figure out what that analysis tells us in terms of how much we save. So we can go to our project manager and tell them, if you can get rid of this risk, you're going to save 20 days on the project. Now, Safran will just do that for you automatically. So what Safran will do, I'm just going to check something here. Okay. So we can say, okay, at our P70 confidence level, tell me on the overall project, and I can again choose one of my focus activities here. So, again, if I have an intermediate milestone I really care about, I can choose that instead of the overall project, but we'll just choose the project here. And I'm going to say calculate the impacts. Now, what the system's going to do is it's going to run this and tell us for each of our risks, what is the impact that risk is having on the overall schedule. So what it's doing is it's turning one off, running the analysis, turning it back on, turning the next one off, running the analysis. So in this case, what it's saying is that at P70, our procurement delays actually have the biggest impact, because keep in mind, depending on what confidence level you choose, the impact could be greater or less. Poor flying conditions is actually showing up as number 2. So the question that the project manager asked us was, tell me how many days I can save if I can get rid of that poor flying conditions or the ash cloud, one of those two. So let's start with poor flying conditions. That's costing us 30 days at our P70 confidence level. Procurement's costing us 40 days. So again, we can go back to the project team and say, if you can get rid of this risk, you can save 40 days on the schedule. Okay. By the way, if you have any questions or anything, please feel free to put them in either there's a question section or a chat section. So I'm going through this fairly quickly, but if you have any questions, please feel free to put them there and I'll make sure I cover them at the end of our discussion. Okay, now I said I was going to come back to cost. Now I'm going to come back to cost. So let's talk about the cost module. So maybe a little bit of background first of all. Um, for many years, when I was doing cost and schedule risk analysis, we would build two completely separate models. We'd build a cost model and we'd build a schedule model. And the reason we did that is because it was very difficult to build one combined model. Now, there's a couple ways you could do it, and different people did different things to try and build an integrated model. The first one was you could build a cost loaded schedule, which meant that all of the costs in your cost estimate had to be associated with activities in the schedule. Now, the thing is, there are some costs on a project that are not schedule related. So you'd have to create some dummy activity and put the cost on that. You could do it, but it was a lot of work. So, and it was difficult to keep the two of them in sync. You get a schedule update and you get a cost update. You basically have to rebuild the whole thing every time. And like I said, it could be done, and I've done it, but it's a lot of work. So then what people said was, okay, that's too much work. Let's look at something else. Here's what we're going to do. We're going to take the results from the schedule model and we're going to input them into the cost model. So we'll take the distribution that we have for, our hotel costs, our project manager costs, all that kind of stuff, and we'll build them into the cost model. Well, that worked a little better, except that you'd never quite get the dependency between them. You're basically taking the static results of one and feeding it into the other. Um, and there's been some studies done as to how accurate that was, and people like David Hewlett have done white papers and things on it, and basically said that by doing that, by taking the static results of the schedule and putting them into the cost model, it tends to downplay the impact of um, those schedule risks. So, what would be a better way to do this? Well, a better way to do this would be to let us build a cost model separately and then link it as appropriate to the schedule. So what Safran did was they built this cost module where you can put in your cost estimate, and you can build a cost estimate up. You can put like a just a dollar figure if you want to, but if with an uncertainty range on it. So here we've got parts at $300,000 with a range of 240 to $450,000. But you can also get more sophisticated there as well. So you can go in and you can say, all right, what I want to do here, if I go down the bottom here, is I'm going to actually say, so under my transportation, let's say for the sake of argument, I think I can transport everything I need to site for testing in 3 shipments. But there's a little bit of uncertainty around that. Each shipment is going to cost us um, about $300,000, or sorry, about $120,000. So 369 for the three. But there's some uncertainty there in that it could cost, or it could take as few as 2 shipments if we're lucky, or as many as 6 if we're unlucky. So I can build in uncertainty around the quantities required. So in this case, I can say, okay, I think I'm going to need 3, but maybe I need 2, maybe I need 6. So this will change. The other thing I can do is I can build any other formula item in here. So I put one in here for exchange rate. So I've got an assumed exchange rate because I have to buy this overseas. So my exchange rate, I'm assuming, is going to be zero point 0.8, but maybe it'll be as little as 0.75 or as much as 1 to 1, depending on how things are going. So you can build any number of categories in here that you want in order to define what your costs are going to look like. Now, this is not as sophisticated as a tool like At Risk or Crystal Ball, but for most people, this is going to be, you can build enough uncertainty or enough different elements into this cost worksheet that you can model your costs accurately in here. And then we end up with our overall estimate. Now we can have a base distribution on that. And let me just turn off a few columns here so we can see it a little more easily. I'm going to turn off the schedule connection for now. I'll come back to that. Okay, so the next thing that I can do is once I actually have um, my base cost estimate built up, then what I can do is I can start assigning the risks from my project risks tab to my line items. So here's all the risk items that had a cost element associated with them. So if you have a risk item that is schedule only, it won't appear on this list. It has to have a cost impact to show up here. And then what I can do is I can just turn them on and say, okay, this one is going to impact, this one's going to impact. So I can say, okay, these are the risks that are going to impact these line items. And just like I did on the schedule side, I can go to the cost impact tab, and it will show me the overall impact. Not sure why it's formula contains dates. I'm not sure what that one's not working. Let's pick a different one. Okay, it's not going to work for me today for some reason, but it should preview for me exactly what that distribution shape is going to look like, just like it would for the activities. So I've built this thing up now. I've got my costs, I've got my risks associated with the costs, and now what I can do is I can take it a step farther, and now I can say, okay, I'm going to turn my schedule connection columns back on so we can see them. So now what I can do is I can say, okay, how much of this line item, in this case, let's take, for example, our construction resources. is schedule related. So in this case, if I scroll over, I can say here that this cost line item is linked to a particular activity. So if I just open this up, and I can choose as few or as many activities as I want. So I can say, okay, I've got this cost line item here, which is $375,000 or $376,000, and I've 100% linked it to this particular activity in my schedule. So what the system is going to do is it's going to say, okay, it's going to take that $376,000. It's going to split it up over the duration of this activity. And if this activity goes long, the costs will go up. And if the activity goes short, the costs will go down. Now, I don't have to do it 100%. I could say 50% of this line item is linked to the activity. The other 50% is schedule independent. I can link it to multiple activities if I want to. So I think we got an example here somewhere where we got multiple activities. Maybe not, but we can add one in. Oh yeah, here's one here. So in this case, we've added it to two activities. We've said 50% of the costs are on this activity, 10% of the costs are on this other activity. The remaining 40% are schedule independent. Now, what the system's going to do then is when I build all this up, the system's going to say, okay, I'm going to take the base quantity um, and the uncertainty on that base quantity. I'm going to take the base cost and the uncertainty on that cost to come up with an iterative cost on that for this iteration. So it's going to say, you know, I need in this iteration I need 4 shipments at $120,000, so that's $480,000. It's on these activities, so it says, you know, what's the duration of this activity? It splits that money onto the activity. If the activity goes long, the cost goes up. If the activity goes short, the cost goes down. Oh, and on top of that, it also puts any risks on there that you might have. So you have a risk that's 40% likely to fire. It may or may not fire in this iteration. If it does, that cost gets included as well. So there's a lot of moving parts here when we actually do our uh, our risk analysis on this cost worksheet. So let's just take a look at what that looks like. I'm going to run the analysis again, but this time instead of looking at the Gantt chart, I'm going to go to the cost tab and I'm going to scroll all the way to the right, and there's an iteration value here. Let's go up to the top. So our project here is at $9.5 million on our first iteration. Our second iteration is $8.5 million, 8.2, 8.9, et cetera. You kind of see what's going on. So I can go through, and again, I want to make sure that I understand, you know, which risks are firing. So when I click through, when a risk lights up, it's firing. When it grays out, it's not firing. So you can see that different iterations, different risks light up or gray out. I can also go over here and see for this iteration what the costs are doing, what the duration of the activity is. So again, I can step through and just make sure everything's moving the way I expect. When I'm happy with it, I can hit complete. And we'll go back to the distribution graph. In this case, we're going to go to the cost view. So here's what our cost looks like. Now you notice that when I looked at it on a schedule, you can see we had that distribution shape that kind of had the two peaks in it and then it kind of ramped down. You can see our cost distribution is quite different. Our cost distribution is more like a normal distribution. And in this case, the probability of us finishing the project on budget is actually sitting at about 13%. To get to P70, which is $8.9 million, we need about $600,000 in contingency. Okay. Now, the same things hold true for the tornado plots. So I can look at the tornado plots on a cost basis, and I can see here's the things that are really driving my costs. So in this case, the big item is material costs, not a big surprise. I can do sensitivity analysis on a cost basis. So again, if I um, tell the system to recalculate on costs, it'll run through and it will tell me how much money I can save by getting rid of each of my cost risks. So in this case, the transportation quantity, remember we had that, we could have 2, 3, or as many as 6 shipments. Well, that's having the biggest impact. If we can get rid of that, we could save ourselves around $1 million, $1.2 million. Um, so all of that allows us to do analysis of the schedule, allows us to do analysis of the cost worksheet. But here's where it really all comes together. And we're just about out of time, but we'll get this in. And that's the scatter plot. Now, the idea with the scatter plot is the system shows me, here's all the results. Each of these dots represents one iteration with a combination of cost and schedule. So in this particular iteration I'm hovering on right now, which is iteration 742, I finished on February the 21st at a cost of $8.7 million. Um, and you can see here that there's some color banding in here. So my 0 to 50% confidence or joint confidence is green. Then I go to my 50 to 70. Then I go to the red, and then for items above that. All right, so what does all this mean? Well, the thing is, I said that I was like 2% likely to be um, to finish my project on time, and I think I was 12% likely to finish on budget. But what I really want to know is, what is the joint probability that I'll achieve both my cost and my schedule targets? Well, in this case, what the system's saying is that my JCL, which is here, is about 1%. Not too surprising, because if I was to take 2% times 12%, I get about 1% joint confidence, right? That they're both going to be successful. And that represents these dots in here, right? So here's the few results I had where I was on time and on budget. Now, what I can do though, is let's say management has said to me, we want a 70% confidence level, but not just on schedule, not just on cost, we want a joint 70% confidence level. So how do I get there? Well, what I can do is I can look at these dots at this point here where I'm changing from my JCL range of 50 to 70 to my JCL range of 70 100. So I can say, okay, right here, I've got a confidence level of 70%. I'm finishing in on May the 7th at a cost of $9 million. Now up here, I'm also sitting at a 70% confidence level. I'm finishing on April 24th at a cost of $9.2 million. So what if you look at this closely, where you've got that interface between the red dots and the orange dots, you basically have a range of values that the project team can work to that are all 70% joint confidence. So what that's telling me is that through that range, that's where the project team can trade off cost and schedule and still be 70% confident of being successful. So if schedule is more important than cost, well, then what I can do is I can spend a bit more money to save some time. If money's more important than time, I can give up some time to save some money. And you can see it's basically a curve here. People call this the JCL necklace because it's a number of dots on a curve. Now, at some point, what happens is this goes vertical, which basically means you can spend as much money as you want. You're not going to save any more time. On the other end, it goes horizontal, which means you can give up as much time as you want. You're not going to save any money. But in between, through that inflection curve, there is where the project team can trade one against the other. And there's a lot of white papers and things and analysis on the different things that you can trade off and how all of that works. But this just kind of gives you an idea of what the scatter plot lets you see. So um, that's a very quick high level overview of Safran. I'm going to open up. If you have any questions or anything, we'll try and get them answered. Um, okay, so what's the best advice for a professional in the area of risk management, someone who wants to get into risk management? Um, so there's a couple of things you can do. There's a lot of really good online material that talks about best practices and things like that. Um, both PMI and AACE both have very good guides as to risk management. There are also some very good textbooks about risk management that are out there. Um, so um, Probably the best thing though is to do the self-directed training through AACE or PMI. Go to Safran's website. They've got some great white papers there as well about risk analysis. There's a question here. What do I mean by hits? So when I talked about hits was when we were back here and we were looking at the distribution graph. So this is what I mean by hits. And what hits means is how many iterations did a particular value come up. So in this cost analysis, you can see here that I've got my, um, this is about, this is a strange scale, say about 15 here. So my $8 million value came up 15 times in the 1,000 iterations, or 15 hits. Up here, where I get up to my $8.6 million, that came up around 120 times, say 118 times out of 1,000 iterations. So we would say 118 hits for $8.6 million. All right. If there's any other questions, feel free to put them in the chat or in the questions section. Um, and I'm just going to wrap up my final slides here. So let me stop the screen share. So people all over the world are using Safran. Safran's been hugely successful. Particularly, we have a lot of clients who are in the U.S. Department of Energy has very much picked this up, and it spent a lot of time and effort on working with Safran. But we have clients, again, as I said, all over the world who are using this tool. Um, if you have any other questions, I see there's no other questions in the chat, and we're a little over time, so probably we need to wrap it up. But here's our contact information. If anybody would like to reach out to us, my contact information is here. Um, and feel free to reach out to us, and then we can answer any questions that you might have. So thanks for joining us. At this point, we'll wrap it up.